Hello everyone. So in this video, I am going to discuss about Cauchy-Riemann equation and then differentiability and then what is analytic function. So what is Cauchy-Riemann equation? Cauchy-Riemann equation is nothing but some simple components of partial derivative. So let me introduce what is Cauchy-Riemann equation. If f of z equal to u of xy plus I v of xy is given any function, and you are knowing that where u of xy is real function and v of xy is imaginary, because we know that here f of z is given u of xy plus I of vxy. So u is the real part of the function and v is the imaginary part of the function. So when you can say this function will satisfy CR equation at some points z naught, where z naught we can say x naught y naught. If first component, if dou u by dou x, derivative of u, where u is the real part of the function, dou u by dou x, this must be equal to dou v by dou y, and dou u by dou y equal to minus dou v by dou x. Means if you are going to differentiate u, real function, with respect to x, so this must be equal to imaginary function derivative with respect to y. So uh, and the second component is what? Differentiation of u with respect to y partially. This must be equal to minus of dou v by dou x at x naught y naught. So first we are differentiating u with respect to x, and second time we are differentiating u with respect to y. And in the first component we are differentiating v with respect to y first and then with respect to x. So if any function is said to be satisfy CR equation, if both the components should be satisfied. For example, in some question you might be getting first component satisfying and second not satisfying. So overall you can say that function does not satisfy CR equation. So we can satisfy CR equation, we can check at any point 0, 0, 1, 1, 2, 2. We can check at any point. So let me give some examples. For example, if we have to check whether this function will satisfy or not satisfy CR equation. So first example, we can take here f of z equal to, simple example I am taking, f of z equal to, we can take here z conjugate, and we know that z conjugate is nothing but x minus iy. So what is real part of this function? Easily you can calculate. Real part of this function is what? X, and imaginary part v of xy. V of xy is what? Minus y. So first component is what? Dou u by dou x. Dou u by dou x. This must be equal to dou v by dou y. So are we getting this one? Dou u by dou x is what? 1. And dou v by dou y, what we are getting? Minus 1. So 1 cannot be equal to minus 1. Similarly, we can check second component. Dou u by dou y. Dou u by dou y is what? Minus dou u by dou y is 0, because you are looking u does not containing any y function, and dou v by dou y will be what? And here also you can see v also does not contain any function of x, so dou v by dou y is also 0. Sorry, dou v by dou y is, dou u by dou x is 0, and dou v by dou y is minus 1. Dou v is containing y, so dou v by dou y we are getting minus 1. So dou u by dou y, this is 0, and dou u by dou y, here actually second component is dou v by dou x, not dou v by dou y. Dou v by dou x. So dou u by dou y 0, and dou v by dou x, dou v by dou x is also 0, because v does not contain any function of x. So here we can observe that second component is satisfying, but first component failed. So what we can say overall, this function f of z does not satisfy CR equation at what points? At what points? So this function does not satisfy CR equation at any points, because if derivative of u and v, if it was having some function of x and y, so that time we can check whether for x equal to 0, it might be both component equal, for x equal to 1, for x equal to 2, we can take some values of x and y. But here we are getting here 1 and minus 1, so this cannot be made equal for any x and any y in any complex number. Second is already we are getting 0, but overall we can say this function does not satisfy CR equation at any points. So let me take second problem. If you are saying, if you are taking second problem also you can take. Yeah, if I am choosing this function fz equal to fz equal to mod z square, if I am choosing mod z square, and if you remember, if z value is x plus iy, then what will be mod z? Mod z is what? Mod z is nothing but x square plus y square, real square or imaginary square. And it is given here mod z equal to z square. So z square will be what? X square plus y square. So this function is given nothing but x square plus y square. So here I have not specified any point. So we can check for general point. So if I will ask you what is real part of this function, simply you can answer real part of this function is what? X square plus y square. And imaginary part of this function v of xy is, because this function does not contain any imaginary number, imaginary function. So v of xy is what? 0. So now we can check first component. What is first component of CR equation? First component of CR equation, we know that dou u by dou x. Dou u by dou x is what? 2x. And second is what? Dou u by dou x must be equal to dou v by dou y. So dou v by dou y, because v is 0, so dou v by dou y is also 0, and dou v by dou x is also 0. Dou v by dou x is also 0. So dou v by dou y is 0. So according to first component of CR equation, so 2x equal to 0. 2x equal to 0. This will imply x equal to 0. And similarly, this is first component. Second component is what? Dou u by dou y. This must be equal to minus dou v by dou x. So from the second component is what? Dou u by dou y. This must be equal to minus dou v by dou x. So let me assume here this is A1. So dou v by dou x we are getting 0. Dou u by dou y is also 0. So 2y equal to 0. So this will imply y equal to 0. So if you will observe here carefully, so CR equation is satisfied only at x equal to 0 and y equal to 0. So CR equation is only satisfying x equal to 0 and y equal to 0, because first component we are getting 2x equal to 0. So this equation for what value of x it will satisfy? For what value of x it will satisfy? X equal to 0 only, because if you are choosing x non-zero 1, 2, 3, 4, 5, so left hand side is non-zero quantity and right hand side quantity 0, which is not possible. So and similarly in the second component also 2y equal to 0, y we are getting 0. So CR equation is satisfied only at 0, comma 0. If you are making x non-zero or y non-zero or x non-zero y 0, so in that case, the CR equation will fail. Next example. So in this question, we came to know that this function is only satisfying CR equation at z equal to 0. Third example we can take. If I am taking f of z equal to simple function z, and z is nothing but what? X plus iy. X plus iy, then real part of this function is what? Real part of this function u of xy is x, and imaginary part of this function v of xy is what? Y. So what is first component of CR equation? Dou u by dou x. This must be equal to dou v by dou y. Dou v by dou y. So this will imply dou u by dou x is 1 and dou v by dou y is also 1. So first component satisfied. Second component, dou u by dou y equal to minus dou v by dou x. Second component is what? Dou u by dou y. This must be equal to minus dou v by dou x. So dou v by dou y is what? Because u does not contain any function of y. So this is 0. And second one is also because minus 0 means 0. So this is also 0. So these two equations, these two components are satisfied at all points. This is not satisfying only x equal to 0 or y equal to 0, because 1 equal to 1 for all x, y belonging to complex number, and 0 equal to also 0. So this function will satisfy CR equation at all points. So I hope now CR equation is cleared. Next concept is differentiability of a function. What is differentiability of a function? A function fz is said to be differentiable. I am discussing in a complex number, because real variable differentiable function you are aware already. Real function, real function and complex function, just I want to tell you most important property. दोनों में बस एक ही अंतर है, रियल वेरिएबल डिफरेंशियबिलिटी और कॉम्प्लेक्स वेरिएबल डिफरेंशियबिलिटी में बस एक ही अंतर है, वो लिमिट का अंतर है बस। रियल वेरिएबल में क्या होता है कि x और ये जो लिमिट टेंड करता है उसमें केवल दो पॉसिबिलिटी है, या तो आप लेफ्ट अप्रोच कर सकते हो लेफ्ट हैंड साइड से, या तो राइट हैंड साइड से। बट कॉम्प्लेक्स में क्या होता है कि हमारे पास इनफाइनाइटली मेनी वेज होता है। So, in real variable differentiability and complex variable differentiability is the only limit is making difference, otherwise no difference. In real variable, just I want to remind limit x tending to c, where c was some real number, f of x minus f of c divided by x minus c, and that was equal to f dash c. But in real variable case, only we are having two way, and here we are having infinitely many way. So if this limit will exist, f of z minus f z naught by z minus z naught, if this limit, because here, if you will see, limit z tending to z naught is already applied to this. So if this limit exists, then only we can say function is differentiable, and then that limits must be equal to what? F dash z naught. And limit z tending to z naught means what? Again, we have to choose some different path. And if along each path limit we are getting similar, then we can say function is differentiable. Otherwise, we can say function is not differentiable. Yeah, just 1 minute. Yeah. So let me take some example how to check differentiability of the function. So let me take first example. If you are having this example, fz equal to, I will discuss 2-3 example. F dash equal to, suppose z conjugate. First example. Second example, we can choose mod z square. Third example, we can choose mod z. And these all function we want to check differentiability at z equal to 0. So let me start. Let me take first example. So first example is given fz equal to z conjugate. So we can write here limit z tending to z naught. What is z naught here? Z naught is the point at which we want to check differentiability. So we are interested for z equal to 0. So limit z tending to 0, f of z is given z conjugate minus f of 0, f of 0 divided by z minus 0. Some student also problem because f0 is 0, but how f0 0 is 0 you can see here. Fz is given what? If I will write in more generalized form, z is what? X plus iy, and z conjugate is what? X minus iy. Correct? Now, how I am getting f0 0, that I am going to explain. So, if I will take x0 and y0, then we can get f0 equal to what? 0 minus I into 0, 0 minus 0 is 0. So, simply we can calculate value of function which is coming 0. So, this we can write limit. Now you can convert because z is tending to 0, as already I explained. If z is, because z is what? X plus iy. If z is tending to 0, then what? X को भी 0 पे जाना पड़ेगा, y को भी 0 पे जाना पड़ेगा. So limit x tends to 0, y also has to be 0, and x also has to be 0. So limit x tends to 0, y tends to 0. Z conjugate we can consider what? X minus iy and divided by what? X plus iy. So this is simultaneous limit. Now I think you are thinking about limit and continuity, what we have discussed some problem. So because this is what? Simultaneous limit. So now this simultaneous limit can be converted into one limit. Either we can convert this entire limit into x limit or y limit. So we want to convert in one directional, because if both will tends to 0, then we are not able to see the effect of x and y together. So because of that only we are converting into one variable. So let me take along x-axis. If I will choose path along x-axis, along x-axis, what will be y? You are knowing y is 0. So we can get here limit x tends to 0, because y is 0. So then we can get here x by x, and which is equal to 1. Similarly, we can choose here limit along y-axis, along y-axis, along y-axis x should be what? 0. So in that case, we can get here limit y tends to 0. If x is 0, then we can get here minus iy by plus iy, and which is coming out to be minus 1. So what we can say? Because in differentiability here limit will play very important role. If limit is coming unique, if limit you are getting unique, then you can say function is differentiable. But you are looking here along x-axis we are getting 1, and along y-axis we are getting minus 1. But so we are getting two different limit along two different direction. So this function is what? Not differentiable at z equal to 0. I hope this concept is clear to you. So because one more example I have written here, mod z square and mod z. So let me discuss about these two example. Yeah. So first let me discuss about third question. F of z equal to mod z. F of z equal to mod z. Mod z अगर if you remember, mod z क्या होता है? Under root real square plus imaginary square. So this you will get x square plus y square. Mod z is what? Under root x square plus y square. Again, if I will ask you, first let me calculate here f of 0, so that this we can use. What will be f of 0? F of 0 means x is also 0, y is also 0. So you are looking here 0 plus 0, which is equal to what? 0. So now we can apply the definition of the differentiability limit z tending to 0. Why 0? Because here we are interested to check at z equal to 0. So limit z tends to 0. F of z is what? Mod z minus f0. F0 you are getting 0, and divided by what? Z. So this final you will get this equal to limit z tends to 0 mod z by z. Now we can convert in xy limit, because this will be easy for us. Limit Z tends to 0 means what? X could be 0, Y is also tending to 0, and mod Z is what? Under root of X square plus Y square, and divided by what? Mod Z, and Z is nothing but what? X plus IY. So finally we are getting this limit, and again we can check along X axis and along Y axis. So if I will choose here along X axis, along X axis, along X axis, what will be Y? Y equal to what? 0. So this limit is coming out to be limit X tends to 0 under root of X square and whole divided by X. And you remember under root X square is not X, but this is what? Mod X. So this equal to limit X tends to 0. This is what? Mod X by X. And when you will define mod X, because we know that mod X is X if X is greater than 0, and minus 1 if X is less than 0. So this limit is plus or minus 1. So you are looking here, only one path is sufficient to prove that this function is not differentiable, because modulus function can be defined in two ways. If X is greater or equal to 0, then X. If X is less than 0, then minus X. So X, when you are choosing X greater than 0, we should get here 1. If X is less than 0, then we should get minus 1. So we are getting plus minus 1. So only one path is sufficient to prove that this function is not differentiable. And this you keep in mind, because some student, they might be thinking how mod X square is, how under root X square is mod X, because under root X square is also distance from X to origin 0 comma 0, and mod X is also representing distance of X from the 0. So both functions, both geometrically, both are same. Under root X square is equal to mod X. Now last third example is given. Third example is given, fz equal to mod z square, and mod z square is nothing but what? X square plus y square. Again you can calculate f of 0 is what? F of 0 is what? 0. And also one more property I hope you remember, z into z conjugate is what? Mod z square. This is very famous property in complex number, because z is what? X plus iy. Z conjugate is what? X minus iy. If you will multiply both, then you will get x square plus y square, which is equal to mod z square. So this limit, this what you will get? F dash 0, this equal to limit z tending to 0, f of z. In place of mod z square, can we write z into z conjugate s? So z into z conjugate minus f0 is coming 0, and divided by what? Z. So this equal to what? Z and Z will be cancel out. So this equal to limit. Now you can convert in one variable or two variable. We can convert into two variable. This equal to limit. You can convert now. Z tends to 0. X is also tending to 0, and Y is also tending to 0. And Z cancel out. So Z conjugate is what? X minus iota iy. So this equal to what? If X is also tending to 0, so you will get 0. Y is also tending to 0, 0. So finally you will get what? 0. So you are looking here, this time limit we are getting unique and finite also. So this function is what? Differentiable. Now many student, they might be thinking, why this time sir you have not taken a different path? Why I have not taken different path? If this function was given like rational function, x plus iy divided by x minus iy. So in that case, actually, why we are converting into one variable? Because if I will tend x is also tending to 0, y is also tending to 0, so we can get 0 by 0. But here everything is clear, because in the previous cases we are getting some rational function x plus iy by x minus iy, and then if x and y both tending to 0, so we were getting 0 by 0, then we have converted into along x-axis, along y-axis we have taken. But here, because this function is defined at x equal to 0 and y equal to 0, so no need to choose different path. If your function is not defined, if you are getting some rational function, so in that case you can convert in one variable by considering x-axis, y-axis, or any other path. So this limit is coming to be 0, so this function is what? Differentiable at z equal to 0. So I hope now differentiability concept is clear to you. Now what is analytic function? Our third topic is what? Analytic function. A function fz is said to be analytic at z equal to z naught if fz is differentiable and each at z equal to 0 and each neighborhood of z equal to z naught. What is neighborhood? This actually you have to understand the concept of neighborhood. What is meaning of neighborhood? I will explain in one variable, then I will come into two variable, because analytic function and differentiability is slightly different. If a function is differentiable at z equal to z naught, if anyone is asking what is connection between differentiability and analytic, so every analytic function is differentiable, but converse is not true, because in analytic function differentiability is also needed in each and every neighborhood of that point. That one point z equal to z naught is only not sufficient. That function should be differentiable in each and every neighborhood of z equal to z naught. For example, if I am giving you this example, we know that x is belonging to real number and here 1 belonging to real number also. If anyone is asking what is neighborhood of 1, so neighborhood of 1, this is what x equal to 1. So here this point and this point, let me draw here by different color. So what is meaning of neighborhood? If I am choosing this, we can consider what? 1 plus h, and this we can consider what? 1 minus s. So this open interval from 1 minus h to 1 plus s, this is called neighborhood of 1, where h is what? H is very small quantity, where h is very small quantity and greater than 0. So if anyone is asking neighborhood of 1 means what? This we can write, we can add something slightly which is greater than 0. So we can say like 1.00009, and here 1 minus s should be what? This like 0.99999. So these two are the neighborhood of x equal to 1. Similarly, some student they are thinking neighborhood of x equal to 1 is 2 and 3. No, 2 and 3, just we are jumping from x equal to 1 to 2. Neighborhood means what? We have to take a very close interval near x equal to 1. We have to slightly move forward from x equal to 1, and we have to move back side from x equal to 1. We slightly difference. So x equal to 1, neighborhood means what? 1 plus h and 1 minus h. Agar if I am choosing this one from set of integers or set of natural number, अगर अभी मैं अगर 1 को अगर नेचुरल नंबर से इफ आई एम पिकिंग, तब क्या होगा? ये x इक्वल टू 1 है, अगर मैं इधर का कोई पॉइंट लेता हूं 1, ये हो जाएगा 1 प्लस h एंड दिस विल बी व्हाट? 1 माइनस h. अब 1 plus h and 1 minus h is belonging in natural number, because 1 plus h is what? 1 plus h is like some fraction quantity, fraction, or you can say some 1 point something something like that. So this does not belong to natural number. 1 minus h is also not belonging to natural number. इसका मतलब कि नेबर, अगर if anyone is asking you 1 का नेबरहुड क्या होगा नेचुरल में, नेचुरल नंबर में, सो देन दिस इज व्हाट? एम्प्टी सेट, क्योंकि हमें 1 का नेबरहुड ही नहीं मिलेगा, क्योंकि नेचुरल नंबर में 1 के बाद 2, 2 के बाद 3, 3 के बाद 4, बीच में कुछ नहीं है. बट इन रियल नंबर दीज पॉइंट्स आर व्हाट? ये सब पॉइंट इसमें डेंस है. तो यहाँ पे रियल नंबर में वी आर हैविंग सो मेनी पॉइंट्स नियर x इक्वल टू 1. सो नेबरहुड 1 प्लस h एंड 1 माइनस h. Now if I will explain same in complex number. So for example, if this point, because in complex number everything we are discussing in a plane. So suppose this is what? This is one complex plane, and this is what? Point. Z equal to Z naught I am choosing. So Z equal to Z naught, this is point. Not Z equal to 0. This point we can assume Z equal to Z naught. This point we can assume that Z equal to Z naught. Or you can assume here Z equal to Z naught. So what is meaning of neighborhood in Z equal to Z naught? We have to choose one neighborhood. और complex में neighborhood मतलब क्या होता है? ये this is a open disk. This is like open disk. All the points near about Z equal to 0. So one disk we can assume. Disk means what? It you can consider like a circle, and here this is radius. This we can consider one circle, and we know that equation of circle in complex form is what? Mod Z minus Z naught. This is what? Less than. We can assume radius of the that disk is R. So Z minus Z naught is less than R. So this will be what? This is all the points are coming to the neighborhood of this Z naught. Because if you will open this interval, then what we can get? We can get here Z is this is greater than some Z naught plus R, and here less than Z minus R. So these are the neighborhood points. So complex प्लेन में neighborhood क्या होता है कि उस पॉइंट के along हम एक डिस्क ले लेंगे, वो सब neighborhood होगा. तो then meaning of differentiability is what? Function should be differentiable at z equal to z naught और इस and each neighborhood of z equal to मतलब इसके हर एक neighborhood में, and that neighborhood can be infinite. That neighborhood can be infinite. तो उसके neighborhood में भी होना चाहिए. And if x equal to 1 you are discussing in real variable, so this is what? Neighborhood of x equal to 1 means 1 plus h and 1 minus h. But same question, if you are discussing in natural number, neighborhood of 1, 2, 3, 4, 5 does not exist, because you there the concept of jumping will be there. After 1 you will get 2, 2, 3. But in complex number, neighborhood means what? हम जिस पॉइंट पे हमें डिफरेंशियबिलिटी चेक करना है, हम उसके नेबरहुड में एक ओपन डिस्क ले सकते हैं, और उस डिस्क के सभी पॉइंट्स के लिए फंक्शन डिफरेंशिएबल होना चाहिए. देन ओनली we can claim that function is analytic. So analyticity is the stronger condition than differentiability. Now in next lecture I will explain how to check analytic function and how to check neighborhood of a function, neighborhood of a point in a function, and what is connection between this analytic function, differentiability, and analytic and CR equation. Because this connection is very important. What is how we can connect if a function is differentiable, whether this is analytic or non-analytic. If a function is satisfying CR equation, then what we can say? If CR equation does not satisfy, then what we can say about differentiability and analyticity? So these concepts I am going to discuss in next video. And here I will also explain how you will choose neighborhood of a point. So thanks, keep watching.